Okay, this is Unity tutorial 5.0, moving platform. Okay, so for a moving platform, what we need first is we need our platform. We need to make it move. So the way we're going to do this is we're going to set 2 points. We're going to have waypoint A and waypoint B. Okay, so we have point A and point B, and we're going to tell the platform to move towards 1. Okay, then when the platform gets close to this point, when it's almost at this point, we're going to tell it to stop moving towards that one and start moving towards this one. And then when it gets close to this one, we're going to tell it to start moving back. Okay, and so if we set this up correctly, we'll have a platform that moves back and forth, back and forth. So apart from our point A and our point B, we need this platform to move at a certain speed. Okay, so we want to tell it how fast to move back and forth, or up and down, or any direction to any direction really, as long as it's a straight line between these 2 points. So we want to tell it to move at a certain speed. Another thing we need to keep track of is should the platform be moving towards waypoint A or towards waypoint B? And we're just going to use that with a bool. So the speed is going to be a float, and the bool is going to be called toward point A. And so if it's true, we know the platform is moving this way, and if it's false, the platform is moving towards B. And we'll be switching this bool in order to make this change directions. Okay, so let's go to Unity. Close that. Go to Unity. Okay, so here is our level so far. So first let's make a platform really quick. So we'll go to create in our hierarchy, 3D object cube. That's going to give us the cube. I'm going to move it. I'm going to make it so we can. I don't know. We'll just put it over here for now. I'm going to make its scale 3, 3. So 3 in the x, 3 in the z, and in the y will be 0.5. So we just have a little platform over here, and we're just going to make it go back and forth here. So there's our platform. Let's give it a color. So I'm going to open up my materials folder and create a new material and call it, what color don't we have yet? How about teal? I like teal. So we'll just apply that to our new platform. So one thing that's going to come in handy later on is we actually don't want to move this platform. We want this platform to be the child of something else that we move. And I'll explain that to you later on. But in order to set this up, let's just create an empty, and let's child it to the cube and set its position to x0, y0, z0. That'll put it exactly where the cube is. Now let's drag that empty game object out and then child the cube to it. So now we know that the cube and the parent are in the exact same spot, and when we move the parent, it also moves the cube. Okay, and that's just going to come in handy later. I'm going to rename this empty game object to moving platform. Okay, so we have our empty game object and our cube, which is at position 0, 0, 0, rotation 0, 0, 0, inside of this moving platform. And that's to keep our scale at 1, 1, 1, and I will explain that a little later. So now we need to make our script. So let's go to our scripts folder, go to create, C# script, name it moving platform. Notice that my script name is in Pascal case, so the M and the P are capitalized and no spaces. And that's because script names get turned into our class names. And class names we want always to be in Pascal script. So we're not going to use the start method. So let's delete that. We don't need to initiate anything. So let's look at let's go back to Photoshop. So we need some facts we need to know about our platform is that we need to know which point it's traveling towards. We need to know its 2 points, and we need to know its speed. So for the points, we're going to use transforms. And I'm going to set them to public so we can assign them later. So public transform waypoint A, public transform waypoint B. We also need a float, that is our speed, and a bool for which way are we moving. So let's add those to our properties. Oops. Public float speed. Okay. And then actually our bool doesn't need to be public. So bool moving towards A and our semicolon. So there's our 4 properties. 3 of them public, 1 of them private. Types transform, float, and bool. So now we need to, in our update function, because we want it to constantly be moving, we need to move between A and B. And I'm going to talk you through how to do that. So actually, to make things easier on ourselves, let's make a new method, a custom method, not a special Unity method like update, called move toward position. Okay. So there's our method. It's got the void type. It's got the name, move toward position, 2 parentheses for arguments, and 2 curly braces for the body. So in the arguments, we want to get the transform to move towards. So we're going to say transform new position. Okay. So inside of this, we're actually going to inside this method, we're actually going to make the platform move. But before we do that, let's just set up deciding which platform to move towards. So in our update, we want to check to see if we should be moving towards A or moving towards B, and then move towards that position. Okay. So we're going to say if moving towards A. So that's our conditional. So if moving towards A equals true. Okay. And so if moving towards A equals true, and then our 2 curly braces, and then after the if curly braces, we can just do an else. And so that means if moving towards A is false, it will do what's inside the else. So if it's true, it's going to do what's inside these first set of curly brackets, and if it's false, it's going to do what's inside the second curly bracket. So if moving towards A equals true, we're going to say move toward position, and there's our method we just created with the argument it needs. We're going to move towards position waypoint A. Okay. So notice that this actually doesn't do anything yet, but we can still use it because it's defined correctly, right? And so this is really handy for just setting up structure of code. So later we can fill in what actually is going to happen. But it's nice just to visualize. So if moving towards A equals true, we're going to move toward position A, right? So if you're supposed to move towards A, we move towards A. If moving towards A is false, we're going to move towards waypoint B. Move toward position waypoint B. So now we just have to do the code where we actually move the platform. So what we're going to do first is we're going to find out how far away the platform is from the position it's trying to move toward. And we're going to, so that's going to be a float. We're going to call it distance. Okay. And we're going to set it equal to, we're going to use a vector3 method. So vector3 dot distance, which is going to return the distance as a float. So that's why we have a float here, between A and B. Okay. So so A is going to be our moving platform's position. So we're just going to say transform dot position, and that's referencing the moving platform's position. B is going to be our new position, which is a transform dot position. Okay, so we take this transform's position and where our current platform's position is, and we get the distance between them. The next thing we're going to do is we're actually going to move this platform's position. So we're going to say transform dot position equals, and we're going to use another vector 3, and we're going to use lerp. And lerp stands for linear interpolation. Linear interpolation. Sorry, lerp stands for linear interpolation, which means which basically means we're going to move from two different points at a steady speed. Linearly interpolates between two vectors. So we're going to take two positions and move between them in a straight line, which is exactly what we want to do, right? We just want to do it over time. So what we're going to do is we're going to move between where the platform's currently at and where the platform is going. So that's new position dot position. And we're going to do that over real time. So time delta time times our speed. So that's how fast it'll be moving. And we want to divide this by distance. And the reason we're going to do that is because we want this to move at a constant speed. So we don't want it to go really slow and then speed up in the middle and then slow down again, and then goes and then speed up, like go back and forth. We want it to move steady, and so the best way to do that is to divide the speed by how far away it is. And that means as the distance gets smaller, our speed will actually increase, but at a steady rate. Just take my word for it. We can go more in depth into it later. So we move using lerp. We move between these 2 points, calculating the time in which we want it to take, and then in here we want to check to see if distance is less than, we'll just say 0.5 f. So half a unit. I say that's close enough. We can always adjust the positions if we need to. But if distance is less than 0.5, we want to say moving towards A equals exclamation point, the opposite of moving towards A. Okay? So if moving towards A equals true, we're going to set it to the opposite of true, so false. And if moving towards A equals false, we're going to set it to the opposite of moving toward false, which is true. Okay? So what that means is our bool is going to always be switching back and forth whenever the platform reaches the waypoint. All right. So this is all we're going to do for now. This is going to move the platform. We're going to have to do one more thing. But let's go back to Unity and check to see if we have any errors. Just my mouse. Okay. So let's go to moving platform, which is the empty child. Notice the cube is underneath, and that's going to come up in our next segment here. But let's add a component. Let's search for moving platform. So there it is. Okay. So now we have 3 things to fill out. 2 waypoints and a speed. So we can set the speed right now. We need to create some waypoints. So the way I do waypoints is I like to use spheres. So I'm going to create a sphere, and I created that as a child, but we need to drag that out actually. So we have our first sphere, and I'm going to change this name to waypoint A. I'm going to duplicate it, doing Control D, or you can right click on waypoint A, go to duplicate, waypoint B. Okay, so we have waypoint A and waypoint B. So I'm going to separate them. So I'm going to move waypoint B over here, waypoint A over here. Click on moving platform, and now we can drag these into their slots. So waypoint A gets waypoint A, waypoint B gets waypoint B. And the reason I like these spheres is because you can see where they are in the world. And once they're set up, you can just select them, turn off the mesh renderer, turn off the sphere collider, And so now they're invisible and you can't collide with them, so it's like they're not there. But it's really helpful, like if you want to, say you want to move this to a new location. It's a lot easier to move a sphere than it is to move an empty game object. So now we have our two waypoints that we're going to move between. They're assigned to our platform, and they go a certain speed. So let's see how it works. I'm going to hit play and move over here. There's our moving platform. So here's here's why we're not done yet. So if I jump on this, notice it moves underneath me. Okay, I don't move with the platform. It just slides right out from underneath me. And you can try it yourself, but it's very hard to stay on. So what we need to do is we need to make sure that when the player, I'll draw this. So when the player lands, on the platform, we want the player to move with the platform, right? But then when the player leaves the platform, we want to stop them from moving with the platform. Okay? So how do you think, what does that sound like? That sounds like when if we want two things to move together, we make one of those things the child of the other thing, right? So if we make the player the child of this platform, we can make it so the player moves with the platform. And then when they leave, we can remove them from being the child of the platform. And so what we're going to do is we're going to set up a trigger box. It's just on the top of the platform. And when the player enters that trigger, we're going to set them as a child of the platform. And that's going to make it so while the player's on the platform, they'll move. And this is why we made the moving platform script its own object and not the cube, the moving platform, is because we don't want the player's scale to get messed up when they become a child of this platform. Okay, first we need to set up our trigger. So we're going to add a component. We'll call it a box collider. So we'll add a box collider. You can see that's a tiny little trigger. So we're going to click Edit Collider and drag the bottom up and drag the left out. And you can see, maybe it's kind of hard to see, but I'm grabbing these little points and I'm moving them. And I'll drag that one out. I'll drag that one out. And so that gives me a box collider here, which fits just on the top. We can set these values. I'll set these values so it's to even numbers, so it's easy for you to get it. 0.275, 0.7, 2.5. Okay. So if you're having difficulty kind of grabbing these handles and editing the collider this way, you have those exact numbers. There we go. Yeah, so now that we have that set up, oh, it needs to be a trigger. So now we want to use our onTrigger enter and onTrigger exit methods. So let's open up our script and add two new methods. Below move toward position, we'll add void onTrigger enter, void onTrigger exit. Don't forget your parentheses and curly braces. So we have two new methods here, and they each need an argument. They need collider other and collider other. Okay? And so what we're going to do in both of these is we're going to check to make sure it's the player entering. So we're going to say if other.gameObject.tag equals player, and if other.gameObject.tag equals player. Okay, so if when we enter the trigger, we want the player to become a child of the moving platform. So the way we do that is we say other.transform dot set parent this dot transform, because it needs a transform. Okay, so that's what that's saying is we take whatever entered our trigger, which is going to be the player, and we set its parent to this. So now the player will become a child of the platform, and then when the player leaves that trigger, we're gonna we're gonna we're gonna set the player's parent to null or nothing. Okay, so the player will be free to move wherever they want again. So this is going to work out really nice actually. So let's try it out. I'm going to hit play. Let's go find our platform. Back and forth. Here it comes. So I'm going to jump on it. Oh. Ah! I fell. Okay. So you can see that that didn't work. So let's try it again. Let's make sure that this is working first. Oh. So it looks like I got unset. So maybe we need to make this trigger a little bigger. So let's say its Y size is 2, its Y position up a ways, and let's try it out again. There we go. So by making the trigger bigger, I didn't accidentally leave it before leaving the platform. So now we're moving with the platform. When we jump off, we're no longer a child. So land on it. And so you can see over in our hierarchy that the moving platform now has the player as a child. And when we leave, I'm going to highlight the player. When we leave, ding, they are now no longer a child again. Okay? So you can see our code is working as we wanted it to. Ah, I missed. Okay, so that's it for the moving platform for now. Before I sign off, I'm just going to go over here and zoom in a little. So this is a little easier to read so you can check your work if you're getting some errors. And just to review, we have our 2 waypoints, our speed and our bool, if we're moving towards A. So if we're moving towards A, we want to use our custom method to move towards that position. If we're not moving towards A, we want to move towards waypoint B. Now our custom method, move towards position, gets the distance between the 2 points and then moves the platform. So this platform's transformed to position, gets changed to move towards whatever the new position is. So whatever the argument is, we move towards that new position at a speed times time.delta time divided by distance. And then if we get close enough, we swap towards which waypoint we're moving towards, right? So if we get close enough, we switch this bool. So moving towards A gets switched to the opposite. So if we were currently moving towards A, we switch to false. And so now we start moving towards this waypoint. And then finally, we added these onTrigger enter and onTrigger exit methods in order to trap the player as a child of the platform when you're on the platform. And that will make sure that our player moves with the moving platform. Okay, great.